Consistent hashing is a technique used in distributed systems to efficiently distribute data or load across a set of nodes or servers. It's particularly useful in scenarios where the number of nodes can change dynamically, such as in web caches, content delivery networks, CDNs, and distributed databases. Traditional hashing techniques, like modulo hashing, divide the data space into fixed-sized partitions and map each data item to a specific partition based on its hash value. However, this can lead to imbalances when nodes are added or removed from the system, as the mapping of data to partitions gets disrupted. Consistent hashing addresses this issue by providing a more dynamic and scalable approach. The main idea behind consistent hashing is to map both nodes and data to a common hash space, typically represented by a ring. Each node and data item is assigned a point on this ring using a hash function. When a data item needs to be stored or retrieved, the hash function is used to determine which node is responsible for that item based on its position on the ring. The key advantage of consistent hashing is that when a new node is added to the system or an existing node is removed, only a limited amount of data needs to be remapped. In traditional hashing, adding or removing a node could require remapping a large portion of the data space, causing significant disruption and potentially overloading some nodes. With consistent hashing, most of the data remains mapped to the same nodes, and only a small fraction of data needs to be moved to neighboring nodes. This makes the system more stable and scalable as the number of nodes changes. It's worth noting that there are variations of consistent hashing, such as virtual nodes, also known as virtual replicas, which further enhance load balancing by allowing each physical node to be represented by multiple virtual points on the ring. Overall, consistent hashing is a fundamental technique for achieving efficient data distribution and load balancing in distributed systems while accommodating changes in the node set without major disruptions.